Comet. A small body orbiting the Sun with a substantial fraction of its composition made up of volatile ices. When a comet comes close to the Sun, the ices sublimate, go directly from the solid to the gas phase, and form, along with entrained dust particles, a bright outflowing atmosphere around the comet nucleus known as a coma. As dust and gas in the coma flow freely into space, the comet forms two tails, one composed of ionized molecules and radicals and one of dust. Comet nuclei range from a few hundred meters to tens of kilometers across and are composed of loose collections of ice, dust, and small rocky particles. The coma may be up to 15 times Earth's diameter, while the tail may stretch beyond 1 astronomical unit. If sufficiently bright, a comet may be seen from Earth without the aid of a telescope and may subtend an arc of 30 degrees, 60 moons, across the sky. Comets usually have highly eccentric elliptical orbits, and they have a wide range of orbital periods, ranging from several years to potentially several millions of years. Short-period comets originate in the Kuiper belt or its associated scattered disk, which lie beyond the orbit of Neptune. Hyperbolic comets may pass once through the inner solar system before being flung to interstellar space. The appearance of a comet is called an apparition. Physical characteristics. Nucleus. The solid, core structure of a comet is known as the nucleus. Cometary nuclei are composed of an amalgamation of rock, dust, water ice, and frozen carbon dioxide, carbon monoxide, methane, and ammonia. Comets with a higher dust content have been called icy dirtballs. Coma. The streams of dust and gas thus released form a huge and extremely thin atmosphere around the comet called the coma. The force exerted on the coma by the Sun's radiation pressure and solar wind cause an enormous tail to form pointing away from the Sun. The coma is generally made of water and dust, with water making up to 90% of the volatiles that outflow from the nucleus when the comet is within 3 to 4 astronomical units of the Sun. Bow shock. Bow shocks form as a result of the interaction between the solar wind and the cometary ionosphere, which is created by the ionization of gases in the coma. As the comet approaches the Sun, increasing outgassing rates cause the coma to expand, and the sunlight ionizes gases in the coma. When the solar wind passes through this ion coma, the bow shock appears. Tails. In the outer solar system, comets remain frozen and inactive and are extremely difficult or impossible to detect from Earth due to their small size. As a comet approaches the inner solar system, solar radiation causes the volatile materials within the comet to vaporize and stream out of the nucleus, carrying dust away with them. Jets. Uneven heating can cause newly generated gases to break out of a weak spot on the surface of comet's nucleus, like a geyser. These streams of gas and dust can cause the nucleus to spin, and even split apart. Orbital characteristics. Short period. Periodic comets or short-period comets are generally defined as those having orbital periods of less than 200 years. They usually orbit more or less in the ecliptic plane in the same direction as the planets. Long period. Long-period comets have highly eccentric orbits and periods ranging from 200 years to thousands or even millions of years. By definition, long-period comets remain gravitationally bound to the Sun. Those comets that are ejected from the solar system due to close passes by major planets are no longer properly considered as having periods.